Alright, so we're not actually doing anything new today. We're just going to be doing the same skills we learned yesterday, but applying it to word problems. But the tricky thing about word problems is just even kind of figuring out what it is, what information we have, and what we can actually use. So what I do is I underline all the important information as I read the problem. So for example 1, tickets to a local movie were sold at $4 for adults, $2.50 for students. If 430 tickets were sold for a total of $1,210, how many of each type of ticket were sold? So what is it that we don't know? What's our unknowns here? The number of adult tickets and the number of student tickets. So we have to define those variables. What do you guys want to call adult tickets? A? Okay, now this is the important thing for word problems. For every word problem, when you are defining the variables, you have to write A equals number of adult tickets and you want S for students. Student equals the number of student tickets. Okay, you have to write that because if you used A or S, X or Y, M and N, I don't know what X means. I don't know what A means unless you actually tell me. Okay, so A is the number of adult tickets sold, S is the number of student tickets sold. So let's look at the total number of tickets sold. If I sold 430 tickets, how could I write that as an equation? 430 tickets total. A is the number of adult tickets. S is the number of student tickets. Now, Gina, what would I put?
A plus S equals 430.
That's right. A plus S equals 430. Okay, now a lot of the rest of the information all has to do with the amount of money. So let me give you guys this situation first. At $4 a ticket, if I sold one adult ticket, how much money did I make? Okay, if I sold 2 adult tickets, how much money did I make? $8. If I sold 5 adult tickets, how much money did I make? $20. How are you figuring that out? How'd you do it? You multiply the number of tickets by the price, right? Okay, so then how could I represent a number of tickets sold? How much money would I have made? If I don't know how many number of tickets I sold, that would be 4 times A, right? Plus, what about student tickets? 2.5 S equals, so this is how much money I made from adult tickets. This is how much money I made from student tickets. How much money did I make total? 1210. It will always be set up this way. First equation is talking about the total number of units sold or bought or whatever. The second equation has to do with the amount of money or that kind of thing. Okay, so they did not tell us specifically which method to use, so we can use either substitution or elimination. It does not matter. I'm going to use substitution on this one. We'll use elimination on the next one. Okay, so let's use substitution on this one so you can have one example of each. So, because it does not specify which method to use, you get to pick which method you want to use. I'm going to use substitution on this problem. Okay, so that means I need to get a variable by itself. Why don't we get A by itself? So we're going to subtract S from both sides. So that's going to give me A equals negative S plus 430. Okay, and I always put them in parentheses because now I'm going to substitute that in for A right here. So let's write a new equation. That's 4 times A, which is negative S, plus 430, plus 2.5S, equals 1210. So then let's distribute. That's negative 4S plus 0, 12, 16, 17, 17, 20. Plus 2.5S equals 1210. Let's combine like terms. So negative 4S plus 2.5S. What is that going to give me? Negative 1.5 plus 1720 equals 1210. Subtract 1720. So that's negative 1.5S equals negative 1720, 510. Divide both sides by negative 1.5. I get S equals negative, or not negative, 340. Should not come out negative. 340 what? Student tickets. And since this is a word problem, it's okay for us to leave our answers separate. We don't have to write them as an ordered pair. We just have to specify what they are. So S is 340 student tickets. Now I want to solve for the number of adult tickets. So that's plugging it back in. A equals negative S, which is 340, plus 430. So that's A equals positive 90, right? Adult tickets. Does that make sense, guys? So example 2, a fruit stand sold 16 pieces of fruit for $7.30. They sold apples for 50 cents each and oranges for 40 cents each. How many of each kind did they sell? What variables do you guys want to use? A and O? Okay, that's what I was just going to tell you. So if A is the number of apples sold, if you want to use O, I use a cursive O. So I do it this way, a cursive O, so that I can tell that it's not a 0. It has happened before in previous classes that kids use O as their variable, and then halfway through the problem think that it's a 0, and the variable went away, and they added an extra 0. So if you want to use a different letter, that's fine. I'm going to use a cursive O. If you want to use R or N, it really doesn't matter. Since I already wrote the O, I'm going to use O equals number of oranges. But exactly, O looks like a 0. So that's why I use a cursive to differentiate it, okay? So what I want you guys to do right now, will you by yourselves see if you can set up just the equations? You don't have to solve it, just do the equations. For the number of the pieces of fruit sold, what did you put as your equation?
A plus O equals 16.
Exactly. A plus O equals 16. That's exactly right. Okay, what about the price? How can I represent the price as an equation? Anybody? How much do apples cost? 50 cents. So that's going to be 0.50 plus, how much do oranges cost? 40. So 0.400 equals 730. Make sure you remember the decimal for 730. Okay, there's a lot of decimals in here, and I really don't want to deal with that. So what do I need to multiply by to get rid of the decimals? Anybody? 10. Yeah, let's multiply by 10. That's going to move decimal over one space. So that's going to give me, and I'm going to write my new one off to the side, 5a plus 4o equals 73. So those zeros don't really make us whole, they still make us whole numbers, so we don't have to move two spaces. Okay, so look at this guy and look at this guy. Can I eliminate anything yet? No. So we want to use elimination method. I can't eliminate anything yet. So do you guys want to eliminate the O's or the A's? O's? Okay, so let's do O's. So what do I need to multiply by to get rid of the O's? Good, -4. So I'm going to write that up to the side also. So that's going to give me -4a minus 4o equals -64. So when I add the two equations together, what am I going to get? Okay, what's -4a plus 5a? 1a, or just a. -4o plus 4o, that's going to give me 0. They cancel. Equals -64 plus 73. What's that going to give me? 9. So, whoa. So a equals 9 apples. Okay. Now I need to solve for O, and I'm going to take that 9 apples. I could plug it into this equation. I could plug it into this equation. I could plug it into this one or this one. I will get the same answer no matter what. I'm going to plug it into this guy right here because it's a lot simpler. So we have 9 plus O equals 16. Subtract 9 from both sides, and we get O equals 7 oranges. Okay. So for example 4, the check was for $470 total, and there were $20 bills and there were $50 bills, for a total of 13 bills. So my variable is the number of each type of bill. So I'm going to let T equal $20 bills, and F is going to equal $50 bills. Okay, those are my variables. So the first one we want to do is add up how many total bills we have. So T plus F is equal to 13 bills total. Okay, that doesn't change. Now I have to look at the amount of money involved. How much is a $20 bill worth? 20. So this is going to be 20T. Plus, how much is a $50 bill worth? 50. So plus 50F. And then how much did those total add up to? 470. So it looks like they give you less information, but you still have the same amount of information. Okay?